So we can tidy up and delete all that, which brings us to the end of this lecture. To wrap it up, we've created a pod. We've seen that a pod has a certain self-healing as it restarts, for example, if it has failed for a certain degree. At least if you set the proper restart policy. You can see that there's even more resiliency if you use a replica set. And with a replica set, you can describe a template on how to create a pod and create many instances of a pod. They are called replicas in the specification. You can see that when you delete a pod of a replica set, the pod will be recreated. You can see that each pod has a different identity. It has a different name. IP addresses will change. And we've introduced, therefore, the service. The service has a fixed IP address, unless it's a headless service, which we'll cover later. But it has always a fixed DNS name, which uses the Kubernetes internal DNS. In our case, it was a core DNS. We have also seen that if you change the service, the IP address of the service changes. And in order to avoid that, you may want to refer to the service's DNS name, which systematically derives from the name of the service and the name of the namespace, as well as the cluster domain. We have then seen that a service can be used to temporarily access the application or whatever is behind the service by using kubectl-proxy. We've also seen that you can use in a shell or in an interactive container and use the internal DNS name to access the service, but this service wouldn't be accessible to the outside, to any other user. In order to make an application accessible to the outside, you need a pod or a replica set controlled pod. You need a service connecting to the pod, and you need an ingress connecting to the service. The configuration of the ingress is specific for the particular ingress implementation you're using. In our case, we've been using the Nginx ingress with Any9's Kubernetes on parse-any9s.com. With its particularities, we've figured out how to generate an SSL certificate, a self-signed SSL certificate. If you want to do that properly, you can use Let's Encrypt to create a free one that doesn't cause that many browser warnings. We've seen how we generate that certificate and key file, and we've also seen that we can and have to import those two files into a Kubernetes secret, and that we pass on that secret to the ingress configuration. So in the ingress configuration, there is a reference to the backend, which refers to the service, as well as a reference to the host, which is our subdomain, as well as the secret where the certificates are. So now we have an application, and if this application gets more traffic and more traffic and more traffic, what we could do easily, because this is a stateless application, we could go to our replica set, which and increase the number of replicas, update, and now there are 4 applications running. I think it's service. Yeah, it's also an abbreviation. So you can see that there's a service, and that now where we have 4 different replicas, we have 4 different backends. This means that our ingress now takes all the incoming requests to this service, which will then load balance across our different pods. Well, you can see the difference because they all do the same thing, but we now have a load balance system across 4 pods. So this is very simple with Kubernetes. You create an ingress, you create a service, and a replica set with arbitrary number of pods, and you'll have a load balancing right away. If individual pods die because, for example, of application level issues that occur from time to time, you'd have a self-healing, and you can also easily scale horizontally by adding more replicas to your replica set. Now, a problem with the replica set will be if we update the application, we have to take down the replica set and replace the replica set with a new container image, which means replacing all the pods, and this will create a downtime. We'll look into that the next time a bit closer, and we'll also look into how deployments can be used to have more control over the way replica sets are updated if applications need to be updated. So thank you very much for your time. See you in the next lecture.